This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. One of the downsides of using through-hole components is that they need holes to go through. In this video, we will continue fabricating the printed circuit boards for the variable positive power supplies. The setup I'm using for hole drilling for the printed circuit boards is an industrial-type handheld drill strapped to a drill press stand, and together it makes a cheap drill press. There are two clamps. One clamp is holding the bottom of the drill, and the other clamp is the top of the drill. It makes for a rather sturdy and stable arrangement. The problem here, the drill bit must be precisely perpendicular to the drill press table. On the drill press base is a mini milling table. It has precise control over X and Y axes. To clamp the printed circuit board to the mini milling table, T-slot step clamps, two of them. The clamp consists of a top clamp portion, which is held to the T-slot by a T-slot bolt. One end is clamped to the printed circuit board. The other end is held in place by a stepping block. If it were not, there would be a kind of a seesaw effect on the top clamp portion, so the step block stabilizes the clamp. Clamp is difficult to set up, at least for me. However, it's universal. Three of these things will clamp almost anything to the milling table. In addition to this, I'm using two parallel bars, and the only function of these is to hold the printed circuit board above the milling table so that when I drill through the printed circuit board, I'm not drilling through the milling table. I'm going to be cutting these two panels apart and then clipping them together in alignment, but before I can do that, I need to drill some alignment holes, and I'll be using a number 22 wire to clip those two panels together. Looking for the correct drill gauge, which is 64 for 22 solid stranded wire. Now I'm drilling these 3 alignment holes per panel. You need 3 holes to align the panels. Any more would be enormously frustrating, and any less would be useless. Basically want a solid, dependable wire that I can run through these holes and twist and clip the 2 panels together. Don't want it too thick, don't want it too thin. And the holes need to be very tight. Now we're putting this number 22 wire through these alignment holes. Okay, this is not an easy thing to do. It's very tightly spaced, as it needs to be. The idea here is that once these 2 panels are clipped together, I only have to drill 1 set of holes, which is very attractive from my point of view. Get this bleeping wire through this bleeping hole here. I'm going to do it. I know I'm going to do it. Okay, now I've got them. Twist the wires together, make sure that they stay in place. Having aligned the 2 panels together, I need to align those combined panels to the Y-axis of the milling table. Once I've done that, drilling becomes much easier. Since the whole thing has been laid out on a 0.1 inch grid, if I align it on the y-axis, then I can go right across on the x-axis without having to align every hole in 2 dimensions. Now I'm aligned and I can start drilling for real. I'm starting to drill these power transistors. Seems to be a light here in the way. I'm sure the director will catch this anytime soon. Okay. The rest of it is pretty mechanical drilling. It's mind-numbing, however, and the problem is to stay awake and stay alert, or these holes will not be drilled properly. The alternative to using this milling table would be to drill by hand, maybe using some sort of clamping arrangement, but still drilling by hand. And that's fine if one has a steady hand. I would think if you're drilling by hand, you'd want to drill just one card at a time. Well, who knows? It depends on the steadiness and concentration of the individual. If you notice the drill bits as they're turning, this is a pretty stable setup. There's no wobble as the drill turns. There's some wobble as I press down on the bit. The board is a little more flexible than one might imagine. To some degree, the bit flexes in response to that. So I'm using a very slow drilling speed, which I also prefer for precision. Oh, keep on drilling. I'm trying to keep the epoxy fiberglass off the top so I can see what I'm doing. It's difficult for me to see this because it's little lighting considerations. I've got a camera on one end. Ideally, I would need to be able to take a very close-up look from 2 perpendicular directions to make sure that the drill bit is properly aligned, but it looks like it's going okay. Close enough to the center. There are some critical pieces to getting the spacing of these holes right. Transistor footprints need to be fairly close to reality, and of course there's this 14-pin dual inline IC. As one might notice in these videos, I'm using new transitions. I was getting entirely too dizzy using long-winded crossfades, and so I'm opting for more surgical transitions. You don't get to see quite as much as you could with crossfades, but you don't get quite as dizzy. It's quite a number of holes. One of these days I should tally up the total number of holes. I think one might be astonished. It looks to me like about 50, maybe a little more. I don't know. I'll count them up when I have nothing better to do. Talk about nothing better to do. Counting holes on a printed circuit board. Maybe I won't do that. The board is not the best I've ever done. One can see that some of the traces have been undercut and kind of thinned out, but it's not terrible. There's only one instance, but not on the panel that I'm looking at right now, where a trace was actually cut. The other problems with the traces have been pitting and undercutting. At one point I was looking at converting this milling table into a CNC machine by basically attaching geared down stepper motors to each one of these axes. There's a project in the planning which I kind of put aside for the moment because I can't really figure out how to get a decent Z-axis, which would be required. The X and Y are fairly precise. The Z needs to have similar kinds of precision. And as you can see, that's not quite easy to do. Those things wobble and shake. I'm drilling with this single drill bit, which is kind of a medium drill bit to be used for this. It's the smallest size drill I can use to be able to cram a number 22 solid gauge wire through. And there are a number of resistors that require larger holes. I'm not going to do that in advance. As I come across the need for enlarging holes, I'll do so with a handheld rotary tool. In particular, I would imagine the power transistor would require larger holes than some of the higher wattage resistors. Well, I am quickly approaching the last of the independent, discrete, inactive component holes, and now eventually I'm going to get to the integrated circuit. Now, I want to reestablish the alignment of the IC. It's basically, I just want to wind up or down on the y-axis and drill a hole without having to change the x-axis for a whole series of lines. Right now I'm just confirming and drill that. Okay, that's pretty good. Oh no! Oh, come on! That's terrible. Gee. I'm going to spend quite some time trying to fix that. That's holes 9 and 10 on the IC have been bleeped up. But we are now at least getting to the point of being finished. Yay, team. In this video, I drilled alignment holes in the variable positive power supply circuit board. I separated the two panels of the board, then clipped them together using the alignment holes. I drilled all the holes in the two boards in preparation for loading and soldering. In the next video, we will continue fabricating the variable positive power supplies. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.